Great to be here. I'm probably as nervous as you guys are. Hopefully, I'm going to inspire you with some talk about some really exciting things, which is a little bit difficult because I'm a sewage engineer, so I'm not sure how excited you guys get about poo, but I certainly do. But I promise the whole conversation isn't about sewage treatment. Just before I start, it's great to see some of those words up on the slides coming up. Teamwork, collaboration, communication, patience, sort of practically, perseverance, planning and time management, because they are all key elements of my job and any job in the future. So it's great that you're learning those skills now. Patience being a big one when you're doing a lot of teamwork, right? So who am I and why am I here? I'm a civil engineer. I'm a project manager with a company called Stantec. Stantec is a multidisciplinary engineering company. We're global. We've got 22,000 people across the world. Big company in the UK, but also Canada, America, Australia, China, everywhere really. But I'm local. I'm based in Exeter, and my work primarily is with South West Water and Wessex Water. And as I said, a lot of water treatment, but mainly my passion is actually sewage treatment. So, my life in STEM, and how did I get involved in STEM? Well, this is me at the beginning of my career. I've done my start time on a construction site, working with Costain. It was probably one of the best times of my life and also one of the most exhausting. So, but how did I get there? So, aged 4, I can remember one of my very first memories of being around engineering was actually here at Exeter University. My father was a professor in the civil engineering department, just over, I can't get my orientation right, but the Harrison building up over there. I can remember standing on a scale model of the River Exe. My father was modelling the hydrodynamics and the fluid dynamics of the river. Not that I knew any of that. All I knew was I was stood on a model that had water flowing through it and was great fun splashing around. At that time, I thought what my dad was doing was cool. But that's about where my fun for engineering left. I went to school, well, you know, all right in maths and science. But when I was 14, my father asked me in the summer to go and help him down on a little job doing what we call surveying or levelling. You might have seen those guys out in yellow jackets, schoolgirls out in yellow jackets with those big meters, look like meter rulers, black and white staffs. That's called levelling, and we take the level and we measure the slope of the road or the hill or whatever we're looking at, trying to work out which way it falls and which way the water's going. I remember standing in a storm drain in Polperro in the middle of summer thinking, this is really not cool, Dad. People walking around, and all I got was an ice cream for it, so cheers. So that daunted and put me off the idea of engineering. But I was a bit stuck, because about 15 or 16, I was doing my A-level choices for A-level. I was good at science, okay at maths. But the problem is I did chemistry, biology, and thought I need to do something with science. Hate to admit it, but I hated physics. Sorry to any physics teachers out there. I just didn't get it. So I wanted to do chemistry, biology, A-levels. And I thought, well, I better do maths, because, you know, you've got to. Again, sorry for maths teachers. But what was I going to do for a career? What did I really want to do? Now, the problem is I have no patience with sick people, so I couldn't go and be a doctor or a nurse. I didn't really want to look in people's mouths, although I know dentists can earn a lot of money. That just wasn't for me. Being a vet, I've got a phobia of anything smaller than a cat. Mice, hamsters, can't deal with them. Butterflies, I'm terrified of anything that flaps. It's bizarre, but that's a genuine phobia. You can look it up. It's called lepidopterophobia. It's a good one. No, I can't spell it. And I also hate anything bigger than a dog. Big dogs, fine. Cows, horses. So that pretty ruled me out of anything to do with veterinary science. As I said, I have no patience, so I couldn't be a teacher. Bless you all in this room. So that really did limit me. I could have gone and done sciences, but I wanted to do something practical. So my dad said, well, what about engineering? I knew about engineering because actually not just my father, but my uncle, another uncle and another uncle are all sort of engineers on both my mum and dad's side. So I was a bit fated, but probably like most 15, 16-year-olds, this is what I thought of my dad's job. Really, every dinner table conversation, and I can tell you this is now what my stepkids and my son think about me. And I also thought it was probably a bit like this, you know, dirty construction. And if I'm fair, there is some of that. That's a recent photo out on site in Dartmoor. It's an amazing new water treatment works up on Dartmoor called Mayflower. Brand new technology, amazing. But I won't go into it. So I thought, well, maybe I better do a bit more research into what this engineering malarkey is about. And I did, and I had a look around, and I thought, well, actually, it's not too bad. It's not as boring as I thought. And civil engineering for me was an opportunity to go and study quite a range of engineering. It's not narrow. Civil engineering covers anything from airports to ports, roads to bridges, to fluid dynamics, to the ground, to environmental engineering. So to construction management and people and contracts and health and safety and legal and law. So I thought, well, it's generally a good catch-all. So I went to Nottingham University, a very general route, a conventional route into engineering. I'd say there's huge opportunities now with apprenticeships, so many different routes into it. You don't have to go to the university, you can get sponsored and work while sort of learning. And many employers now actually take you through college and university and apprenticeships. So definitely always look into it. But it wasn't until the end of my second year that I really thought engineering's for me. I still had a bit of a love-hate, especially the physics side of it. Still had a love-hate. Structural engineering, if you're going to go into it, you do need physics. It is important and it does help. I didn't like it. And my second year tutor was my structural engineering teacher. Yeah, he didn't like me. Anyway, so at the end of my second year, I got a job with Costains, working on a little road junction just outside Exeter, in the sun, in the summer. Junction called Woodley Junction. I don't know if any of you know it, on the A30, just outside Exeter as you're heading towards Oakhampton, Tedburn, St Mary to Cheriton Bishop. And I built that bridge. It's now called my bridge, Sally's Bridge. Well, to be fair, I didn't actually have anything to do with the bridge, but I did have something to do with all the road junctions around it. So if you're going around the roundabout and go off, it's probably my fault because I haven't put the curb in the right place. And I also put in a sort of cattle grid with a hedgehog ramp. These things actually have hedgehog ramps in. They have to make sure you put it on the right side, though, because if you put it in the low side and where all the water is, the hedgehogs actually drown and can't get out. That was a lesson learned. I was on there on site, got a phone call from the site foreman. They can all be grumpy, these site foremen, shouting at me, going, "You put the cattle grid in the wrong way." I was like, right, they're notorious for taking the mick out of you, especially as the students. I was like, yeah, no, I haven't. You put the hedgehog ramp at the bottom. So, what's a hedgehog ramp? Hadn't even known this. But apparently I had, and hedgehogs would have drowned if I put it, because they're always low on a slope, so they drain, so the water drains out, and hedgehogs can't swim, apparently. So anyway, at the end of that summer, I realised that I'd really enjoyed it. I'd had a great summer. I'd earned quite a lot of money. I'd been out in the sun. But actually, what I'd realised is I'd built something. I'd built something that was going to last, that was visible, and someone was going to use. And I'd realised I was starting to use my skills. I'd been using my maths and like sort of setting out where you're lining out, and use my numbers to work out the quantities of concrete. It wasn't complicated, and it was stuff I could do. But it was also enjoyable, interacting and working with those people, the teamwork and the camaraderie. So I decided, well, maybe I'll give this engineering thing a bit more of a go. So I finished my degree. Lucky to say I managed to get a first. And then after a bit of travelling, I took about 6 months off to go and do a gap year, because, you know, that's what students do, isn't it? I got a job with Costain, working on site over in the Port of Felixstowe. That was probably, as I said, one of the most exciting, but also the most exhausting times of my life. I was there for 18 months, and I think I probably worked a good 60, 70-hour weeks. You work weekends, long days. Great fun. We were extending it's a big container port there, the biggest in Europe, and we're extending the quay wall. So we had massive cranes, huge cranes, big tubular metal piles, cranes on piling rigs out in the sea. I say it was like working on a big climbing frame over the water. I get told off because of all the health and safety around that, and they hate me saying that. And the number of radios and hard hats I lost into the sea is unbelievable. But it was brilliant. Rain, snow, sunshine, sunburn, everything. But after that, I decided that actually I had enough of building other people's designs. I wanted something else. I've been there, I've been working a long time. And I actually came back to the Exeter University and came and did a paid research role at Exeter University with South West Water. It was called a knowledge transfer partnership. So I was 2 years, and I was doing a lot of research, like you guys probably have done or are about to do. I was looking into wastewater sewage systems, so sewage treatment works and looking at poo. As my housemate at the time said, I was studying, I got a master's of philosophy because I couldn't be bothered to go all the way and do a doctor's of philosophy, so she was joking that I was becoming the master of poo rather than the doctor of poo. But all of that gave me a great introduction into the world of wastewater and water treatment, research, teamwork and cooperation. And on the back of that, I decided actually I wanted to go into consultancy, become a consultant engineer. That's what I've been doing for the last 13 years. For me, consultancy is fantastic because it covers everything. It goes from the problem solving. It's the very first point through to the very end. You get to go and look at the problem, investigate what the problem is. You then get to come up with potential solutions. And then working with your team, you normally then develop the solution, design it, and then if you're really lucky, you actually get to go and work with it on site and see it finished. And for me, that beginning to the end, being the hero who saves the day, is a fantastic chance. Oops, hopefully that will come back on. And so that was what consultancy for me is the best part of it, is working in teams and solving those problems. And it really is important as an engineer is that you can make a difference. So for me, it's using my STEM skills, but actually what I do on a daily basis does make a difference. I might only be working with sewer pipes, and people really aren't very interested in hearing about them. But the important thing is you care about when it's not working. When you can't flush a toilet or the water's coming back up through your toilet, it's really important then. When it's flooding your garden or your basement or your house, that's when you don't want to see it. The rest of the time, you don't care. And that's a lot of what I do, is actually look at those problems of when it's not working and it's causing someone's life misery, and we go in and solve it. One of the other best bits for me is the treatment work side of it. I promise I won't go into this too much, but this is all about sewage treatment. And if you want to understand, I'm a civil engineer. I did chemistry and biology, and I do use those still in my daily job because sewage treatment works, it really is exciting, I promise you. It's like a cooking pot of biology and chemistry and engineering all in, and I can name about 6 or 7 different types of engineering involved just in the design for a nice sewage treatment works. Because what we've got to do is really important. We've got to take that wastewater and make it so clean that it can go back to the environment and not cause any damage to the environment. And that means putting it back into the river in a state where there's no biological reactions that are going to make the oxygen in the water disappear, so it's going to kill the fish. So it's not going to create that sort of eutrophication, if I remember the right words, like killing off the river. It's not going to have too many chemicals in there, so that it's almost as good enough quality that you can take the water out and drink it. So in that, you will have a process engineer who's a chemical engineer who's looking at what do we need to do to treat that wastewater. You're going to have a mechanical engineer because a lot of it's pumped. A lot of it's systems, there's pumps, there's turning, you've got to get it from one tank to another. You'll have electrical engineers because you can't do anything without power and control panels and computer technology. You will have a structural engineer who is telling you how thick your concrete tanks need to be, because quite often they'll have like water in, but you've got differential pressures, you've got thicknesses walls. And most of the time, as a civil engineer, you're managing the project and you're trying to tell your structural engineer, you've got to get it smaller because it costs too much money to build it too big. You will have environmentalists involved because you can't just go and build things and not worry about the impact on the environment. So quite often you have a lot of nature around because we try and hide these ugly treatment works behind trees and in nice green areas. You will have a geotechnical engineer because quite often if you're digging in the ground, they tell you how you can actually build, because some of our ground is great, some of it's rock, you can't really dig into rock very well, but some of it's really soft ground. You can't go putting heavy tanks on soft ground without them moving. Your geotechnical engineers tell you how you can do that. So there's loads of different engineering involved. And I don't get to even do the fun bit really. As a civil engineer, I'm normally managing those teams, that teamwork, that cooperation. But when you get to build big tanks, and some of those tanks, 30, 40, 50 metres, that's quite good fun, especially when you're there. But one of the best things about my career and using my career in my STEM is that I love travelling. And the opportunities to travel with any career, but we know that doctors and nurses and people have got skills that they can go and travel and move around the world. But as an engineer, you can as well. I've had the opportunity through work and through engineering to work in deepest, darkest Cornwall through to sort of Wales and all around the southwest and the sort of the southern parts of England. But I've also been to Romania with work. The picture there in the snow is looking at the water intakes in Romania. And one of the best bits of those jobs was that we were looking at improving the water quality there, because when Romania was joining the EU several years ago, they didn't have safe drinking water in a lot of these places. Some of the towns didn't even have running drinking water or sewer systems. one of the best jobs we did was actually give clean drinking water to a community where previously they were taking water from a well which had 3 times the safe nitrate drinking levels in. High nitrate levels in drinking water can cause birth defects and premature childbirth deaths, so in infant deaths. So that's an amazing opportunity. As an engineer, you can be life-changing. So I've been to Austria, China with conferences. The photos at the bottom, that's me working in Bangladesh. I've had the opportunity to work with some charities out there looking at housing development and building safer housing for flood resilience, using their local techniques and working with them to improve that sustainability. And more recently in Indonesia. I was out there in April looking at a conference about how to help the communities respond better to the disasters that they live in. The top photo, it looks like paradise, but it's paradise in potentially hell. I don't know if many know much about Indonesia, but it's on the Ring of Fire. This is a Google Earth image, and you see all the big dark blue lines. Sorry for any geography teachers if I get it wrong in here. But those are all the images of the tectonic plates. If you can remember a bit about tectonic plates, you get a lot of earthquake shifts. But also with that, you get volcanoes. And this plan here is Indonesia. So you've got Sumatra, and then you've got the Java Islands, you've got the big section of Borneo in Indonesia, Sulawesi, and all over. They've got the most congregation of sort of volcanoes, active volcanoes in the world. Whilst I was only there for 2 weeks. They had one earthquake which triggered a tsunami warning, and I was just down here at Merapi, right in the middle of Java, and that volcano was active. Apparently it was level 1, so it's fine. It was just spewing lava up to 2 kilometres from the cone, so they have a 5-kilometre exclusion zone. But back in 2012, they had the biggest explosion they've had there for a very long time, killed 35 people, and the volcanic ash spread for 35 kilometres and came down, which you think, okay, it's a bit of ashfall, but that ash has got silica in it, which when you inhale is like breathing in sand. So those things are massive. So as an engineer, you get the opportunity potentially to be involved in these things. We're not going in there to save the day and save those communities, but we can go in and work with those communities to help them improve their resilience and sustainability to actually dealing with natural disasters. So for me, that's one of the benefits of being in STEM in my career. And that's sort of me to wrap up, really. I've sort of probably gone on quite quickly. But as an engineer and using STEM, STEM is an amazing career opportunities. It gives you the opportunity to have a multiple diverse career. So far, I've worked in construction and research and consultancy. Unfortunately for me, I've probably got another 30 years before I can retire and pay off my house mortgage. So in 30 years, I hope I will continue to have a fairly diverse and challenging and interesting career. I don't want to just stop here. I'm just being consultant. I love wastewater, but I want to carry on. I want to use those challenges. And I would say I use my maths daily. I use my chemistry and biology appreciation on my work. And I could probably do with a bit better physics knowledge, if I'm honest. I don't know if many of you know, my superhero is Sir Joseph Basel. I'm not sure if many of you are aware of him. He is a Victorian engineer who, you probably know, he helped solve the Great Stink in London. You know, in the 1800s when it was stinking and Parliament shut, and they had to do something about all the sewage that was going into the streets and the River Thames. He was the guy that eventually came up with a system to build the big sewers in London and get the sewage out. And he's credited, I couldn't actually find the main quote that I wanted, of putting 20 years on the average life of a Londoner, which is something more than any doctor has ever done. But because he just built simple tunnel systems. But he's a bit more than just a sewer guy. He was a city planner, and his vision for sort of the London Water Board and city planning is actually an inspirational image that's actually gone on to lead on to the basis of the city councils that we have these days. But he's credited with having cleaned up London, stopped the epidemics of cholera and sort of the outbreaks of the disastrous diseases that were killing people at the time. And his plan for the sewers and sort of cleaning up major cities also was knocked on to the rest of Europe. So he's amazing. If you get a chance, check it out. The IC's been doing, Institution of Civil Engineers, has been doing a big campaign about their superheroes. And this year it's focusing on water, so I'm so happy. But the last quote is just about change and creativity. I missed off saying it, but engineering isn't just about science, technology, engineering, and maths and the STEM subjects. it is also about creativity. It's also about art. It's about innovation. So the two don't have to conflict. You don't have to just be science. You can be science and arty. You can bring that all, because we've got so many challenges facing us now, and I've seen some of your posters. I think some of you have been looking at climate change and all those impacts that we've got, plastic waste, so many challenges for the next generation that we need to look at, and we need to look at how we do things differently. And sort of STEM careers is pivotal in actually forming our future. So I just wanted to end with a quote that says, without change, there's no innovation, creativity, or incentive for improvement. Those who initiate change will have a better opportunity to manage the change that is inevitable. And that's in the skill sets that you guys have possessed, and it's within your opportunity to change the future. Thank you.
In your line of work, is there the opportunity to go to foreign countries and design and build sewage systems to improve their water quality?
Absolutely. Being an engineer, it's a skill set again that sort of is, you can travel the world with those skills. I've got friends who have recently moved out to Singapore and are working out there. But as an engineer, you've got the core skills. So we've been involved in Bangladesh. Another girl I work with has been involved in working in some of the slum areas out there, and they've been doing exactly that in projects that have been looking at installing very basic sewage systems, water supplies, and that was a big focus of the work that we were doing in Romania at that time, was sort of designing the new water and sewage systems. So you can go out for short projects. It might be that a consultant company has small-scale projects or big projects that's funded by governments or DFID or World Health Organization or all these different funds, or there are charities that are always looking for people to go and help. And there are so many different charities that get involved. There's things like when you get to university, there's something called Engineers Without Borders, which is a bit like sort of, it's a university sort of charity that takes sort of student engineers and places them out in sort of developing countries to do projects like that. Might be able to go and help a community build a rainwater harvesting system, a new schoolhouse, and that's focusing on development. And then when you get a bit older, there's other charities. I'm focusing on engineering because that's what I know, but obviously we know there's Médecins Sans Frontières, CARE, and all these big international charities. There's a charity called REDR, which is originally started as Registered Engineers for Disaster Relief, that focuses on doing disaster relief responses as well and training people up. So there's so many opportunities to go and do things like that.
Lovely, thank you. Right, another question up. Oh, down here first, and then we'll come to the person at the back.
Okay. You said that you get to use your biology A level quite frequently. I'm just wondering how you use it in your career.
So this is the exciting bit about sewage treatment work. Sewage treatment works is all about bacteria. A lot of the process of the treatment is how the bacteria respond to the organic matter in the sewage waste, so basically your poo, and how they break it down. And I get to use it by just understanding what the process engineers are talking about, but there's different conditions that you treat, the aerobic, anaerobic, and anoxic conditions that you put the bacteria in, change the way they actually interact with the organic material and which chemicals they then take out and bind and release. So in sewage treatment works, in certain processes, you have what you might have the aerated zone, the unaerated, and the completely oxygen deficient zone. And you basically stress the bacteria under different conditions. You either overfeed them and then underfeed them and stress them. So I don't directly use it in my designs, but it's the appreciation and understanding of what the engineer's telling me. He's not just telling me, oh, your zone's got to be 30 cubic meters. It's why is it that? Why is it this? Why is it the aerated and why? And then there are different conditions when it won't be. And it's about chemistry as well, because in a lot of sewage treatment works, you get ammonia and you get phosphorus. And those things going into the environment is really bad. So it's also understanding the biological reaction that goes on in the river. If you have high oxygen organic compounds going into that river, I don't know if you've done about eutrophication and weather green of the river and the lack of oxygen. So it's about the chemical oxygen and the biological oxygen demand in the river. So for me, it's all about understanding all that. And the other side of it is the water treatment, when we're taking the water out of the river and understanding what the chemical oxygen demand and what the chemicals and the manganese and various chemicals are in the river, of how we treat that so it's drinkable and palatable to us as humans coming out of the tap. So I don't directly design with it, but it's really, really helped me understand that process and how it works. I think that helps.
How do the chemical engineers and the chemistry side of it sort of come into what you do and how the system works?
So the chemical engineers are the process engineers. They're amazing because we can't design a treatment works without them. So they're the first part of the project. So when we know we've got to treat the sewage from, say it was a new town, the sewage can be very different because it's not just necessarily our waste. You will get waste from shops, commercial properties. There might be a factory involved, especially around this area. There are some like woolen factories and stuff. And the chemical engineers will understand the chemistry makeup of the waste that we've got to treat. But also depending on where we're putting the water, into which sort of type of receiving body, if we call it, whether it's a small stream, a big river, or the sea, the Environment Agency tells the water company, you've got to treat it to certain standards. Some of those standards can be exceedingly tight. If there's a bathing water or even shellfish harbour down the river, you've got to clean it so it's so clean, so that none of that organic material gets into us and makes us ill, or those viruses. So the chemical engineers are the people that actually design the process. They're the ones that say exactly how big all of those tanks need to be based on their knowledge of the chemical interactions that they know need to remove the biological elements, the chemical elements, and then the leftover chemical components to, as I said, there's phosphorus, and phosphorus going into the rivers can be quite bad. So you have phosphorus removal requirements, and that requires chemical dosing and the levels that you do that at. So for me, the chemistry is the best bit, is the most important bit, because we could build tanks any size. Civil engineers will build concrete, whatever you like. We could build square, circular, huge ones, small ones, underground ones, whatever. But without knowing what the sort of retention times and contact times, all numbers and elements that the chemistry and chemical engineers have looked at. And it's changing. It's not a standard process design. It's always changing depending on what comes in and what comes out. If you buy a saline water, salt water is not very good for bacteria, so you've got to design it differently to if you were in the middle of a clean water river. So there's so many different interactions. They design those systems and they're pivotal to it. And water treatment's even more complicated because it's got even more tighter standards because of human consumption. So yeah, the chemistry in that is a lot more than the biology actually. So I couldn't do anything without them. I hope that answers.
That's great. I think one more question there, Mike.
From what you were saying about when you took maths and biology and chemistry, I'm not sure whether you have specific knowledge in this, but I was just wondering, how important do you think non-STEM subjects are in terms of moving into a STEM career?
It depends on the STEM career. Obviously, if it's something very technical like medicine, then you probably need those. I did chemistry, biology, maths, AS French, and general studies, I think. I'm not sure if you do general studies anymore. I didn't do physics, which for civil engineering can be a bit limiting. There were fewer universities that would take me, but there were still some good ones. I think having some non-STEM subjects is really good. It can build up, whether it's geography or history, it's just knowledge and appreciation and understanding. Art and creativity for me is huge, and core STEM subjects are really, really important and are fundamental in the basis. But those extra subjects on top just put you out there, and that different bit of thinking and a different way of thinking. Sometimes engineers come in all shapes and forms. You will get engineers who just want to be pure maths, look at this sort of structural analysis, looking at building members in tension and compression, and they love the complicated cut sums. To the other end of the extreme, where you have environmental engineers, who are still engineers, who really, really want to improve the environment and are passionate about making everything greener and better and less concrete and get rid of all the hard engineering. And I think diverse teams make that innovation come and that creativity and that change. So I'm not sure if I've fully answered the question, but I think non-STEM subjects are really good as an additional to your core STEM subjects if you're going into a STEM career. because it makes you think differently, it makes you see things slightly differently, and it doesn't just blink at you. I hope that helps.
Yeah, I think that's an excellent question, especially a lot of careers. You mentioned international travel as well, so languages can be very important across many different sciences because there is so much collaboration involved as well. That's really quite an important aspect. So one more question.
Thank you. So you said that you were like interested in science, but then struggled to find like your area and like your like career. How do you think the school, like, or your school and like the education system could help you like direct and be aware of what is actually out there?
So unfortunately for my school, they weren't very supportive because I went to an all-girls school that focused very heavily on, if you're doing science, you're going to go and be a medical genius or a veterinary science or something like that. I actually had to push our school to put on extra maths lessons because when I was doing it, you had pure maths, statistical maths, or mechanics. And they weren't going to run the mechanics maths modules because no one else wanted to go and be engineering. Me and my best friend, she went off to do aeronautical engineering and works with the Navy and the wonderful helicopters over there, and she's fantastic, exciting other career, another discipline. So for me, when I went through careers advice at my school, we did a test and they said I could be an air traffic controller or maybe go and be a nurse or something. I think really uninspiring for me. But they did say there are some websites to go and look at, and there are lots and lots of different charities that are trying to get out there to reach the schools. And I know it's a really difficult thing for schools because there's so much information that sometimes it's hard to understand where to look. I would have loved it. There are a couple of campaigns which are focused on women, which are the Women in Engineering Society, WES, or WISE, which is Women in Science and Engineering, that run conferences. But all of the big institutions, so things like the Institution of Civil Engineers, the Institution of Engineering and Technology, all of them try to run school outreach programs, so to try and get schools advice, and they've all normally got local branches and people that will happily come into school, talk to schools about potential careers. So it is a real difficult one for schools to support, because I know you've normally probably got, my school was quite small and we had 60 people in sixth form, but 60 different people with different career potential choices is still difficult for a school. So bigger schools, I know, will struggle. My advice would be to look and guide students to websites to try and look. The first port of call will probably be the big institutions. Every single engineering discipline, if you're interested in engineering, has an institution. So there's the Institution of Mechanical Engineers. Institution of Engineering Technology picks up electrical and electronic and sort of information technology. So they're the biggest. But there's Institution of Structural Engineers, Institution of Chemical Engineering. So there's loads. There's a lot of information, but normally there will be a school's contact within each of those. So I'm not sure that really answers fully.
Thank you very much.
Thanks very much, Sally. I think we're going to move on to the poster exhibition shortly, but could we just say thank you again very much to Sally. That was really fascinating.